All right. So, hi everyone. Are you able to hear me clearly? Let me just start. Let me just give all of you the ability to record. Okay. All right. So wonderful. So, are you able to record? All right. All right. A question from Minta is: could you compare the difference between SQL, Pig, Hive, and Spark SQL on input/output while teaching Hive? Yes. Okay, so okay, let me just see if we could pull out the Pig one. I think that'll be. Let me just give it a shot. Okay, so all right, I'm trying to answer Binta's question. That could you compare the differences between SQL, Pig, Hive, and Spark SQL? Okay, so yes, let's try to do that during the session or post session. Great, great. All right, great to have all of you in the session. So today till now, what we have learned is we have learned MapReduce. We have learned streaming with MapReduce, as in MapReduce is streaming, meaning using any command for doing the MapReduce instead of writing the Java code. All right. A question from David is that the US is starting the daylight saving time tomorrow morning at 2 a.m. Will this affect the class starting time for those of you in the US? Yes, because for rest of the people, the time will remain fixed and accordingly the time will change. So with respect to the IST, the time will remain same, so you'll have to make the adjustments, and maybe we'll have to update that time zone. Okay, so that means so it'll become from tomorrow the okay the right. So for Bintao also, who is in Canada, the time will shift a bit, or with the daylight saving is starting. Okay, okay. So I think in IST, the time will remain the same. For others, they will have to make the adjustment. Okay, jump forward 1 hour. All right. As in your day is going to become bigger. As in, so, all right. That means jump forward 1 hour means, so the time which is now for you today, 2 becomes 3. That's correct. So in the same way, the class will start 1 hour late for you. Because globally, with respect to the IST, the time will, with respect to GMT, the time will remain same. Okay. All right. Great. Great. So a question from Noor is, okay. A question from Noor is, I tried to implement max temperature code in MapReduce. My question is that my code can't run until I comment your code or word count in build.xml. No, actually, it can run. It can run. Let me just take it offline and maybe reply to your discussion. Okay. 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 And post the session. Let me just do that. Okay. Uh, all right. All right. So let me just go over the questions from the beginning. Yes. Thank you, Hitendra. I'm feeling better. Actually, I was just okay after like Tuesday or Wednesday. And a question from, okay, good, good. So I think these questions have been answered. All right, let me allow some more people to record. Is there anybody else who can't record? All right, great, great. Wonderful to have all of you in the session. Should we start now? Today, we are going to start a fresh new chapter. So far, what we have done is we have done hands-on with MapReduce and Hadoop, as in we've learned HDFS, we have learned MapReduce, and we have also learned Zookeeper along with Yarn. So Zookeeper, HDFS, Yarn, and MapReduce, what we have learned so far. Great. All right. So great. Let me just take this URL. It's important to keep it here. Great. All right. So great, great. I've taken the note and let's try to catch up and see if we can solve it. For others also, others can also try to do the same thing, what Noor is trying to do. It'll be quite useful thing to do. All right, wonderful, wonderful. In case you want to do MapReduce programming, you should give it a try. Okay, in the meantime, take a look at the various other problems and code in the GitHub repository in Hadoop examples. So that could be helpful for you. All right, so again, welcome to a session on Hive. Okay, so we're going to do the Hive. A question from Sachin is, which code should I try? The code that you saw in case of the, let me open one more tab. Okay. So here, did you see this? GitHub, big data. All right. So this is the one. Okay. Now you see here you can try these code, as in you can try these examples that we talked about. As in we haven't looked into these examples in detail, but if you are interested, you can take a look at those. All right. And if you want to go into the MapReduce, only then you should try. Otherwise, rest of it is completely okay. All right, so here we go. Okay, though the slides are available in the there. Okay, so actually, you could. All right, let me just give you the PDFs, and this is where. All right. So here, right? Let me just give you the PDF. That'll be easier for everyone. Okay. All right. So this is the one. Okay, so this is the updated PDF. I've just updated it. All right. Great, great. So Hive is basically a data warehousing infrastructure tool. It helps us process the structured data in Hadoop. That is, and Hive runs and resides on top of Hadoop. And it makes data churning really easy. It provides SQL-like queries. So it's actually pretty simple tool. All right. So instead of I think okay. Let me just give you a brief overview. Then we'll do the hands-on, and that will be a better idea. Okay. So why do we need Hive? Question is, why do we need Hive when there is MapReduce? Why do we need Hive? Okay. So developers need whenever developers need to process data or process humongous data, they need to write this MapReduce logic, and that takes a long time. That takes a long time, and this is where the need of tool like Hive arises. So okay, let me take a step back. So when we were doing the MapReduce work, right? When we were doing the MapReduce work, then we were realizing that it is very time consuming. Even for a very simple task like word count, it was taking just too much time for us to write code and get the work done. Also, writing MapReduce is not a natural logic. It's not a very straight logic. It's basically defining the key values and writing the reducer. And that is actually hard even for very experienced programmers. Okay, this is hard for even the serious programmers. All right. So therefore, MapReduce is not practical in case your data is already structured, right? So in those cases, it's better to use SQL kind of interface. It's better to use an SQL kind of interface. The other reason is not only the problem, not only the MapReduce logic is hard for some people, but how would you move so many people who are into databases, already doing pretty good job with the databases, to writing Java code? It is like walking backwards. Okay, so there are relational databases and there are a lot of SQL infrastructure. How would you port existing infrastructure with Hadoop or similar systems, right? Therefore, there was a dire need of a system like Hadoop, Hive, where we could just write queries and so on. The other thing was that users are very familiar with SQL queries, then MapReduce or a new language like Pig. Pig failed because Pig had its own query language, which was not as natural, or it was not that sophisticated as normal SQL. Therefore, Pig did not get adopted much, and that's where the Hive actually excelled. Okay, so Hive's SQLite query language makes data churning easy for everyone. All right. So here is an architecture. Here is an architecture whereby we see this is the architecture of Hive. What you see is this is the boundary that you see is the core of Hive. Okay. So the important part that we must take a look at here is that Hive has a driver. Okay, so we write SQL or we interact with Hive, and this driver converts our SQL into MapReduce. With those that MapReduce logic is executed on top of Yarn. All right. Okay, so that's what it is. Here, what we see is basically driver is the main one, and after driver, so driver converts your SQL queries into MapReduce. Now, while driver is converting your SQL queries into MapReduce, it needs to figure out like which table you're processing, what were the columns in the table, and so on. That data over the data is called metadata, and metadata is kept inside Metastore. So Hive has the heart of the Hive is this driver, which converts any SQL query into MapReduce. But since while converting an SQL query into MapReduce, it would need the information about the table, information about the columns. That data is kept in Metastore. All right, that data is kept in the Metastore. Now, this core engine of Hive that you see is it has multiple other utilities. Okay, multiple utilities. It has CLI, meaning there is a command line interface to the driver, whereby you will when you give a query to Hive, it is going to ask driver to convert that query to MapReduce internally, and then in this process, it would need the Metastore. Okay, in that process, it would need the Metastore. So, so this one is the one that translate or that basically runs MapReduce, and this one contains the metadata, like which table do you want to churn, what are the columns in the table, what are the data types. That is called Metastore. Metastore is generally in relational databases. In our case, it is in MySQL. Now, how do you interact with it? Either using command line interface, or or the Hive web interface. Third one is the thrift server. What is a thrift server? How many of you know what is a thrift server? Nobody? Alvin, Bintao, David, Godwin, Grishma, Hitendra, Maruk, Noor. Okay. All right. All right. So thrift basically is a service. Thrift is a software. You can think of it. Thrift is software as a service kind of a platform whereby it's a tool that can help you convert your code into a proper service layer. So it's a very sophisticated tool given by Twitter. Let's say you are building your own service which will be launched on a server, and you would want many users to access your service. Now, how would you write that service? One way is creating entire thing from scratch. The other way is write the definitions of the service that you want to expose. There is a there's an intermediate language provided by Thrift or other similar service servers. So you write this service definition and then give it to Thrift. Now, all you have to do is implement these methods and rest will be done by Thrift. So Thrift will create a web service. It's a binary transfer protocol, really fast. So the entire work of creating server, exposing API, and even generating clients to your service in every possible language is the role of Thrift server. Now, since this Hive process needed to be exposed to everybody, that's why the Thrift service was created. And this Thrift service has once the thrift service was created, now people could connect to Hive via JDBC or ODBC and other database drivers. So you could actually connect your analytics tool to Hive and query the data using SQL. So let's say you are in Excel. From Excel, you connect to ODBC. From ODBC, via Thrift server, you will be writing SQL query, and those SQL queries will be converted to MapReduce by this. Okay, so that's what would happen. All right. All right. So So basically, let's say you are want to present the data using beautiful charts and graphs in the Excel. So you can actually connect via Excel through ODBC to Hive, and that queries, all those queries will be executed on Hadoop, and you don't have to implement anything else. Okay, so in your BI tool, you can directly connect to Hive because of this. Okay. So we have driver, thrift service, and rest of the driver interfaces. Okay, and then of course Metastore. Now, these are the third-party systems who can all connect to Hive by the way of either of these mechanisms. Okay, we'll be using Hue and command line, and as part of the project, we'll be using the ODBC. And you can also take a look at the JDBC way of connecting it. We'll be giving you an example. Okay, so okay, so a question from Noor is, for example, if we have a database, say Hive in a database in Hive, say DB1, containing multiple tables, so that means that database is available outside Hadoop ecosystem with the help of the thrift. That's right. Who creates the service layer? Who creates the service layer? The service layer is created by thrift. Okay. Say today you are creating this beautiful service, say a server like a phone book or an address book. And all you want to do is you want to ensure that everybody, whosoever using any kind of programming language, should be able to use your service, right? So you have written this very good code, which is working perfectly fine in the local one. Now you want to expose this to the people outside your system, right? One way is just create a website, create your own REST interfaces, like handle each and everything for these methods. The other way is using the thrift service. Okay, so for thrift service, we have done this earlier at in Mobi once. So we basically used thrift server at that time, and all we had to do is we have to write this intermediate language and the implementation. The clients will be generated by thrift, and thrift will also launch your service at a particular port in the network so that other users and other people around the world could access your service at that port. Okay. All right, did I make sense? No. Sachin, you want me to explain once more what is a thrift service? All right, let me just try it. Probably that would help you. So let's say you are trying to build this nice, robust phone book, right? You have like phone book service, correct? Now, this one is basically storing the phone book in your local database. And there are two methods that you're exposing is. First method is get phone number, right? Give in a name, get the phone number. Okay. All right. The other one that you want to see is add phone number, right? So here you pass the name and number, correct? So there could be other, and say get phone number is, this is a service that you want to launch to the people, and their get phone number is, they provide a name of any friend, and you have to give the phone number which they have added in past. Okay, and of course there could be other method like update or delete, correct? So those kind of methods will be there in the similar way, and delete, correct? So you are providing this nice little service. Now, it's working fine if people are calling this service locally. If they call the main method of your program, it's actually doing good. But what you want to do is you want to run it as a service. One way is creating a web server and all that, but you want to be a little more generic. You want people or people using any kind of tools to access your server. Okay, so this is where you expose it like a service. Okay, this is where you expose a service. Now, how do you do that? You basically create something called thrift in we call it in the service definition language. So we define these methods. Okay, so when we ask thrift to run it, so what it does is it generates two parts to it. Okay, one is called the server side, implementation side, and other is, okay, we call it service IMPL, implementation, and the other is called the client code. This can be based on client code in Python, Java, C, C++. It could be in Lisp, or it could be in JavaScript. So it's up to what languages do you specify here. Okay, so thrift will take your service definition and convert it into these two parts. This one you will further modify and implement. This is something you will update the implementation. Okay, right? And this is where basically this methods would be called. So this is the client, and then there will be something called a thrift server, right? Thrift server. Let me just put a diagram here. I hope it makes sense to you. Okay, so here is my thrift server, right? And in this thrift server, what we have is there a way to, all right. So this is the thrift server. Okay. Now this is the one, basically, this is the one to which the calls will come from the user. The calls will come to the user. Okay. So what you do is you basically implement these methods. You don't write any server or anything. You just implement these methods. Client gets the code, and using the code, they can make the service calls. Okay, service calls. Okay, so they'll basically the client basic library will be generated by this thrift ideal. Using that library, the clients can connect to your server and make various calls. Okay, does it make sense to you? No? So there are two phases to it. One is the implementation phase, where you are basically defining this thrift intermediate definition language. And once you have finished writing the intermediate definition is like a contract, okay? Because here one impression of it is going to be given to the client as a library, and other one part will be given to you, which you will concretize. This part you will update the code, and you will implement this part. How would you implement? Internally calling your existing libraries, right? So this thrift server will keep on running, and it will take up this definition, whatever you implement, and start running at a port, listening to the user's call. Users can take this one and they can start calling your service. Some will be calling in Python, using Python. Some will be calling using standard REST interface. Some might be calling using using say Java or anything. It's none of your concern. Everything will be handled by Thrift server. Is it clear, or I confused you further? Okay, a question from Rajani. Is there an example you can show as part of this session later? So I will, okay, with respect to the thrift, I think that will require a session in itself, but I'm sure that you will get the picture of it. Okay, so, mm, right. So the example would be that you just take a look at the thrift code itself. You go to the website. You go to the examples. There you will get the complete life cycle of thrift server. Okay. All right. A question from Grisma is, so it will work only if the definition is present in the thrift server. Okay. And okay, so what is the good question? So it'll work only if the definition is present in the thing. Correct, correct. So this I'm explaining to you entire development phase of a service. So first of all, you write this intermediate definition language, explaining the endpoints. Here you explain the endpoints. Okay, endpoints. And what it does is it generates the server side implementation and client side. This one you basically update with your own code. And then once you're done with it, you give it to Thrift Server. Thrift Server is the one which will make it live, and then it'll start serving to the users. Users need to generate the clients and then start connecting to your Thrift service. Right. In actual cycle, is Thrift ideal in the same physical location as Thrift server? Correct. Correct. But you generally start this process in the development phase. So in the beginning, this is your development phase where you are creating this nice product and exposing to your client. Your client will get the libraries and then say, right, nice, we can now connect to this server using this library. And then they can basically write their code and then start connecting to your servers. While you will implement the backend. Okay, so this is the way it looks like. All right. A question from Sachin is, what is the role of Thrift Server in Hive? So basically, when when you are, say, running a BI tool, right? Say BI tool meaning, say you are running a Tableau, okay, and or you are running, say, Excel. Now, using Excel or Tableau, you would like to present really nicely using pie charts, and you would like to present using graphs, okay? And you would like to show it really nicely to your end users, okay? And so on, right? So basically, using this, you want to do the presentation, but your data is really big, and you can't do the processing using Tableau's local system or Excel's local system, right? So instead of this or any other BI tool, this is BI. Okay, BI or any other system. So instead of you writing this piece of logic, what you do is you you basically connect to the Hive server. Okay, Hive server. Okay, Hive server, right? From here, you send the query. From here, you send the query, send the SQL query to Hive, and you get the results. Okay, you get a table having columns and rows, okay, which you can present here. All right, so this Hive server that you see here is essentially this Hive server is essentially internally it's a thrift server. Okay, I can actually type faster than this. Okay, so you can do this. You can. All right. So this is internally a thrift server. Okay. All right. And when the query comes from SQL side, so what you do is this one basically executes MapReduce, right? MapReduce. And you get the results. Okay. So this MapReduce would be running on multiple machines and so on. Internally, it's going to go on map and reduce, then gather the data back and so on and hence. Okay. So Here you can think of it like reduce phase here. So we executed map reduce here. We got the results. We gave it back to the user. So this is thrift service. So thrift is a generic system. You can create your own server like Hive or any other server. All right. So a question from Robin is, in actual cycle, is thrift ideal in the same physical location as thrift server? So in the development phase, you generally keep this, but just to expose your service to the clients, you would generally like to keep ideal there. Okay. And generally it's a better idea to maintain that ideal along with your service. Okay. Another question is, but in this way, if anything changes at server level, we need to give the updated client library to the user. Very good question, Noor. So whenever these are exact challenges of any new service, correct? Exact challenges are, let's say a particular function needs to be updated, right? Particular function needs to be updated. So instead of you don't want to break the client functionality. So this IDL has various features like optional arguments, or you can define the versions of the API. So using those mechanisms, you can generally defend the version updation. So you keep your IDL to be backward compatible, as well as you rarely change the API, right? If you are changing and you are not able to you are not able to keep the API intact, as well as you are not able to keep the optional parameters which you have recently introduced, then you might have to create a different version of IDL and inform the client that or design the system with the versioning of the IDL, the service layer. Okay. So okay, so that was one. So a question is, so the thrift server helps in connecting to external system, correct? Okay, while Hive is like a batch process that you call a function and it will, you call a command line API and then it will convert. But the Hive server is what makes it possible to be used as a query server, like a database that keeps running all the time, and all you need to do is connect at a particular port. Similarly, Hive server keeps running all the time, and you just need to connect at a particular port. All right. So yes, you can say that thrift server is the one which is making it possible to expose Hive to the worldwide. Okay. A question from Robin is, can Hive also interface with Spark? Yes. So Spark can actually talk to Hive, and instead of executing the same query on MapReduce, Spark will execute that query using its own engine. So what it does is it talks to the Hive server, fetches the metadata and fetches the entire information, and then converts it using its internal conversion engine or translation engine into Spark's MapReduce instead of Hadoop's MapReduce. Okay, so that's how it works. Yes. Okay, that's correct, Hitendra. So Spark is independent of Hadoop ecosystem, but Spark SQL can talk to Hive, fetch the metadata, and do the translation, its own translation. And that's how it works. So let's say you have this data. Okay, let me just draw some data here, right? This is your HDFS. Okay, so what Spark SQL does is, again, Spark SQL also has its own Spark SQL thrift server, Spark SQL server, which is again thrift server, right? So that also basically provide the same functionality as this one, and and you can directly talk to Spark SQL server. The smart thing they have done is whatever tables you have defined in Hive, you can use the same one. Okay, so this one would have the Metastore. Okay, we'll talk about it, don't worry. All right, we'll talk about it. This is Metastore, and Spark SQL is going to fetch the data from Metastore. Okay, you can put the arrow the other way. Let's say that this is here, Metastore is inside this. So from here, it's going to basically get the data, okay, from Metastore, and then I'll just define one more layer here. Parallel to MapReduce, Spark Spark core is there. Okay, so Spark SQL is going to hit core. It's again going to distribute the work, and those machines are going to basically read from HDFS. All right, so basically Spark core is parallel to what we do MapReduce, and Spark SQL is what we have Hive. And the additional advantage which Spark SQL has made possible is that by default you can just use the same Metastore as Hive. Okay, so you don't have to define your tables again. You don't have to create your columns again. You don't have to do anything. You can just use an existing Metastore. All right, so I hope this diagram is clear to all. No? So this is your Hive server. This is your Hive server, which internally has driver and Metastore. Okay, so correct. Spark core generates MapReduce equivalent. All right, so this is the Hive. Good. So this is a Hive server. Hive server runs at port 10,000. Okay. And there are some limitations. Let's talk about the limitations. Though Hive earlier versions did not support row level updates, and still in the industry, people don't generally use the Hive for modifying the records. Instead, Hive is generally used like an analytics engine, which can run your SQL queries on massive scale. Okay, so to run SQL queries on big data, we use Hive. Okay, long back in 2012, when we were processing data, that time the Hive was not mature enough, and we ended up writing kind of a very basic system a system in which we can select columns, we could do define columns, and so on. So Hive did not provide that time, as in Hive was basically that analytics engine. Like you have humongous data, read-only data, or not so much changing data, and you want to process that data. In those cases, you would like to use Hive. And it did not provide the row level updates earlier, even though in the latest versions it does provide. We will also show you that yes, you can modify the records. And so basically, while we are creating tables, we can create tables, we can load data, but we can't update cell, or we don't have a update query in the previous versions, but newer versions do have that. Okay. So good. A question from Robin is, if the ecosystem is currently using MapReduce, and there is a plan to migrate to Spark, can they coexist temporarily until full migration? Yes, that's very much possible. Okay, that's very much possible. Okay, one, adoption of Spark is not going to be a big change in the whole ecosystem. Second, your entire thing could exist. Your HDFS file could exist exactly where they were. Your Hive tables could remain exactly where they are in the Hive system, and you can still query them using Spark. Okay. So Noor's question is, but now we should use Spark SQL, right? Yes, kind of. But Hive is quite useful, and Hive can still be used to a very large extent. Even if MapReduce might look like arcane system, but Hive is still very, very useful. So Hive cannot be ignored. And what I believe is that Hive is going to live for some time. Okay. So a question from Robin, just curious about some software terminology. Does it mean that Thrift Ideal intermediate definition language, that ideal, is the web front end, while Thrift service such as Hive is backend? So Thrift service is actually the web server front end. It provides you a service which you can expose on HTTP as well as non-HTTP ports. Okay, while thrift ideal is something that we do at the time of development. You write at the time of development, you write the intermediate definition language, and that intermediate definition language, one copy, it gets converted into the various languages like Python. All kinds of clients are generated using that IDL. Using did I make, yeah, using the IDL, various kinds of clients are generated while you implement your code. Once you're done with implementation code and you're done with marketing to the customers, your API, then the customers can connect to your thrift server and start using it. Okay, so that's how. So this one is your web front end, which we're going to be exposed, while this is partly internal. Okay, you can distribute this piece of code either using your blog or using your company website. It's called SDK generally. Okay, this is called SDK or driver. Okay, and people use this there. All right. So this process is mostly like a development environment. Okay, so thrift service basically lets you write the backend. It provides the, I said, defined earlier. So this is the one, thrift service is the one is which is running your backend logic. Okay, it's providing the front end to various people, right? And the backend is provided by this. Here, front end does not mean the HTML, JavaScript. Here, the front end is a REST interface. Okay, so thrift service has one face this side. Okay, one face this side. This is your what do you say, the various kinds of implementations, and this side is your code that is running. All right, great set of questions. It is definitely worth knowing these parts. Okay, and because these terms will keep coming, and 90% of the confusion is because of these terminologies. Okay, the software engineering is not hard. It's just that there are just too many terms, and people use terms with the acronyms. Okay, a question from Robin is curious again. Does Hive function the same way as Pig? So Pig was only a command line. Okay, and Pig was a kind of generic, and it doesn't have SQL like structure. Though it is quite useful when it comes to understanding the paradigm that we again talk about the Spark, because Pig did the lazy execution first. Now that lazy execution is used by Spark, that lazy execution technique is used by TensorFlow and many other systems. Okay, so yep. Now the other thing is Hive, since it uses MapReduce, and we notice that when we launch a MapReduce query, there's always this 2 to 3 seconds delay in the query execution. Therefore, Hive is not great for OLTP. What is OLTP? Online transaction processing. Okay, and it's not great for real-time response. Queries have a higher latency. Next is there is a startup overhead for MapReduce jobs. So OLTP jobs have So I'm sorry, I'll start from the beginning. Hive queries, since they are using MapReduce in the backend, and we notice that in MapReduce, there is a time delay, and therefore there is always an overhead of the whole ecosystem. Therefore, the Hive is not suitable for OLTP, online transaction processing. Online transaction processing is as soon as you want to process the transaction within fractions of seconds, and that's not really possible using Hive. Okay, it's great when there is a large data set that is being maintained, and that's what you want to mine. Okay, now let's talk about a bit about Hive. So how many of you are comfortable with SQL? All right, so looks like everybody's okay with Hive, with SQL, right? Okay, all right, no worries. As we see forward that while showing you the SQL query, I'll describe the query in more details, and that'll kind of refresh your ideas of SQL query. Okay, so now let me just give you a brief about Hive data types, then we'll do hands-on. Great. So Hive has the various data types, just like your normal database tables. Okay, normal database tables. What does it mean? It means that just if you have studied databases, when you want to work on a database, you need to define a table first, or you need to use an existing table. So you keep your data in the form of table. And what's the table? Table has rows, table has columns, right? And columns have strict data type. All the values in the column are either of the same data type or are null. Same is true in case of Hive also. So before you begin processing, you define a table. You define a table in Hive, and when you're defining table, you define the columns. And once you have done that, you upload the data into that. That's what we are going to show. Okay. All right. So in SQL, you have these columns, and columns have data type. So in the same data types are also available in Hive. In Hive, why? The same data type, why same data type? Why did not invent their own data type? Because they want existing queries to be easily portable to Hive. Therefore, you will find that there are all kinds of data types. Say, for example, for numbers, you have tiny int, you have small int, you have int, you have big int, you have float, you have double, and you have decimal. Okay, so you can see that there are so many data types in Hive. Why? Again, because the idea of Hive is that anybody who is comfortable with databases should be able to use it. Similarly, what they want is existing queries should be able to easily port it. So what they have tried to do is the data type from Oracle, Microsoft SQL, Postgres, and MySQL, they've tried to collate all of them. And that's why you will notice that there are just so many data types in Hive. Okay. Similarly, you can see that for date time, you have data types like timestamp, you have date, you have for string, you have varchar, you have char, and so on. And then there are miscellaneous like boolean, binary, and so on, right? The one interesting part about Hive is that it is first instance of data types that it has picked up from Postgres. Okay, in the beginning versions, it was mostly Postgres kind of data types. So here are some interesting data type that you may not have seen before. One data type is array. You can define an array. Array have the values and values have data types. So in the array, you can only have same kind of values. So each cell can have an array of values. Second is map. Each cell can also contain a collection of key value, or sometimes you refer it as a map. Sometimes you also refer it as a dictionary. So you can define a column of the data type map by using the keyword as map. So this data type has key in the primitive data type format, while the value could be another map or another complex data type or simple data type. The third one is the struct. In the struct, the struct is very much like map, just that the column values, the key values are fixed. So you could define a class objects and you can upload objects into Hive. All right. You can using this, you can define a column whose value is a complex object. That's right. So array and map must have data type in the values, correct? Okay. Now, there is another interesting data type called union. What is union? Union is a composite data type. Let's say, you know that a particular column might have two different values, but only one value will be there at a single time, right? So for those kind of scenarios, you generally have union. When a particular cell at a time will only have one kind of value, okay, but there could be multiple different kinds of values, right? Now let's take an example of the data type. I'll explain again about the union. Okay. So a question from Vidya is map and structs are similar with the dictionary, correct? Just that in case of struct, the key values are predefined. You cannot add any other key. Okay. All right, I'll show you this example. I think this will make more sense to you. So name is clear, right? So let's say we are defining a table in Hive called employees. We are saying create table employees. The name is a string. Then salary is a float. Okay. Then subordinate. This is the name of the column. 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 And this is the data type. Okay. Here, the data type is an array of strings. So what kind of values could come in this particular column? So we are right now defining the data type of your table. We're defining the columns. And the columns here, the third one, you see, here the third one would have values like this, an array of strings, array of strings. Okay. Now, the next one is deductions. Deductions is a map. Here, you could have anything in the form of key value pair collections. Okay, this is just an example of what could be there. All right, so here is an struct. Here, if you see, in case of map, we did not define what is going to be the key. But in case of struct, we are saying that only these four keys would be there. It'll be street, city, state, and zip code. So these are the four values that could come in, four key values that could come in an struct. For example, this. Okay. Now, next one is the union. So auth column name is of data type union. So this data type, you see, is a very interesting one. It can be at one time, it could be either an integer, it could be either the other integer, or it could be an email string. Okay, it could be an email string. So you can see that at any time, there'll be only one value. You can see here, there'll be basically whatever you store, it'll be only using one memory. The amount of space it would use generally in the databases will not be equal to this plus this plus this, but the overall memory will be max of this data type. Okay, just like in C language, there is a union. In the same way, you have union here. Okay, so Postgres, the data type of Postgres were very much like C. Therefore, the struct was there, the union was there, and the same has been inherited by Hive. All right. Okay. Now, I hope Noor and Sachin and Grisma, is it clear now? Bidao, the idea of a question from Robin. What programming language is used in this example? This example, this one is basically normal SQL. Okay. What could be a practical example of union? Good question, Noor. Let me actually, the example which we have taken is good. Now imagine that you are maintaining these employees or users, that you are maintaining a table. A user could authenticate using internal ID like Facebook ID, or it could authenticate using email. So a user could authenticate either with a phone number or with the email ID. Only one is required, or only one is used by authenticating, right? So this auth keyword, auth column, essentially would have one of the three values at a time, right? Because a user can either log in with Gmail or log in with Facebook or log in directly with email ID or maybe the phone number, right? So out of the four values, there will be only one value at a time. Okay, a question from Bintao is, are all the same? SQL. SQL means structured query language. That's kind of a standard. SQL is a database as well as query language. Okay, while Hive is basically supporting SQL. SQL is a programming language. So as SQL is a structured query language, so Hive is supporting the SQL query language and giving the results from the MapReduce. While Spark SQL also supports the SQL query language, and it can use either its own Metastore, or you can use an existing Hive Metastore, and it will convert the queries into Spark internal MapReduce. Okay, so that's how you can think of my internal MapReduce. We are referring to the Spark core. Okay, now what is the Metastore? In case of Hive, what is the Metastore? Metastore stores the metadata of tables into a relational database. All right. So Metastore stores the metadata of tables into a relational database. Okay. So metadata includes details of databases and tables, table definition, name of the table, columns, partitions, etc. And so this is the Hive's Metastore. A question from Binta is that if I write up the same query in the environment of SQL, Hive and Spark SQL, can I get the same results? Most likely, yes. Okay, just that in case of Spark SQL and Hive, you will get the results on humongous data really fast. A question from Hitendra is Metastore provided by Hive implementation? Yes. Is this same master database in SQL Server? Not really. So is this same as master database. Okay, it's a little different. So when we are defining this table, right? When we are creating this table definition, Hive is going to keep it somewhere, right? Hive does not have its own data store. It will either keep it in HDFS or it'll keep it somewhere else. But so Hive chooses standard MySQL database for keeping this information, that there is a table called employees which has these many columns, and then from where we need to load its data. The data generally Hive keeps in HDFS. The data is capped in HDFS, while this definition of table is capped in MySQL or any other database such as Postgres or anything that supports the standard relational database kind of a model. So Hive basically keeps this information about the table, about the databases in the database. All right, in the usual database. Okay, a question from Robin: what other query languages can be used beside SQL as an option? So here it's mostly the SQL. Okay, though you can define your own methods using Java in case of Hive, but it generally supports the standard queries, standard tables, standard query language. It's in SQL, structured query language. Sorry. Now, coming back to Sachin's question, who converts SQL query to MapReduce job in Java? Okay, this is an interesting question. Question is, will there be the driver will generate the Java code? So it's the Hive's driver which basically converts the SQL into MapReduce job. Okay, it doesn't really generate the code per se and compiles it. Instead, it basically executes the MapReduce by providing the logic. Okay, there is no Java code generation as such. All right, a question from Hitendra. Hive engine does that. That's right, Hitendra. Okay. Question from Timmy. Can we create Hive table with different data formats like Avro, Paraquet? Yes, we can do that. We can do that. You can define, you can specify the data format. So Grishma's question is, so Hive reduces our work of using Java code of MapReduce logic. That's correct. That's correct. So that's exactly the role of Hive is. All right. So now, so we talked about Metastore. Metastore keeps name of the table, name of the database, columns, and we'll talk about partitions and so on in a table. A question from Robin is, in an ecosystem, can I use MySQL in my MS SQL in place of MySQL or any other Metastore? I think you can do that because MS Access also has the Java driver, so it should be possible. Okay. Okay, for keeping only the Metastore, not the data, not the actual data, only the Metastore. All right. Now, so we talked about one Metastore. So Hive, when we say table, right? When we say in Hive that this is my table, table has two parts. One is the metadata definition, like what are the columns, what are the table names, what are the partitions. And on the other hand, the table has data. That data could be humongous, while the definition of table could take few kilobytes of space, right? But the data could be humongous. And for that humongous data, the place it keeps the data is the HDFS. Though Hive can process the data from HBase, it can also process the data from other systems, other kind of systems, but it is predominantly used for processing data that is capped in HDFS. So when you're creating your fresh tables, you can basically upload data into it, and that data would be saved in HDFS. By default, that table goes into a folder called warehouse, and that warehouse is where the data of Hive is by default kept. Okay, so by default, whenever you create a table and upload the data into it, it creates a folder in this apps Hive warehouse on HDFS, and here at the location specified in the tables definition. All right. So if you have defined the location while creating a table, you can specify the location where that table's data will be uploaded. Then the data will be created at that location in HDFS, or if you have not specified any location, then by default, it creates the data here. All right. So we are going to do some hands-on. All right. We're going to do some hands-on. And do you want to do it on the from the hue, or you want to do it from the console? I will suggest that let's do it from the hue. That will be easier for all of us. Okay. Or if you want, you can do the Hive this hands-on right away, but you will have to quickly exit because it has that limitation of number of connections. So we are going to take a look at it. All right, here we go. So I'm logging in into, say, CloudxLab, going to my lab. Okay, I'm going to use Jupyter's console because there I don't have to log in as such. Okay, because it keeps my login password intact, it keeps my session alive. So here I'm going to use that one. All right, so here I go. Now we could do, so I'm just launching Hive. Okay, what kind of error am I getting? It says cannot find a valid. Let me just try a couple of times. It's happening in some of the machines. Okay, this time it worked. So if I say show databases, okay, you can see there are quite a few databases here. We can create our own database, create database, say SG, what's the date today? Date today is 10 March 18. Okay, so see that? I used a command called show databases after I first launched Hive from the console. Then I said show databases. Then I said create database. And I said SG 20 March 18. Okay, you could create your own database. All right. Done. Everybody's done. All right. A question is there any help available? You can generally say help. Okay, it's not there. Show help. Okay, so here it says some statements, but I doubt if there is help available. There used to be some SP help or something. No. Okay. All right, it doesn't show any help. Okay, we'll have to take a look at it. All right, now if I want to use my database, I can use sg underscore 20 March 18. All right, so you can see if I say show tables here, it won't show anything. Okay, so just give me a second. I'll finish this and then I'll take a look at your screen. Okay, now the next part is we did show databases, then we did show tables, then we said create database. We also created this database. Next is we can create a simple table, say create table X and a int. So we could just say create table X and we say int. Okay, so we just said this is our table. All right, so we just created a table called X. Okay, we could now start, we could actually start writing the queries. Okay, what happened to this one? Okay, so this way we are able to create a table. Okay, now I'm going to stop my screen share so that others can help. Go ahead, Robin. Go ahead, Robin. Okay, so let me just take a look at the screen. Go ahead. You could just go to control panel, my server, and say new, and say terminal. Okay, so this is your terminal. When I say Hive, okay, I could exit from here because my work is done. It might take a long time otherwise for you. All right, so Hive clients generally have this problem that only few connections are allowed in parallel, and that's one of the reasons. And you can just try once more. This error is occurring for whatever reason. It's not working for others. No, no, no. So it did not launch at all. Okay, so create database need to be run on Hive. I need to look at this problem because this problem is for Hive, it's very, very predominant. I see. I see. You're also getting the same error, Sachin? Ouch. Cannot find a valid directory there. Okay, let me just see if there is a quick solution and we could launch it somehow. Okay, I'm just logging into my terminal again and trying this. Okay, I see. Quite a few users are facing this challenge and I'll have to take a look at it. Okay. Okay, just give me a second. I'll ask my team to take a look at it quickly. And somebody from my team can take a look. This could be because of some space issues on other machines. Let me ask one of my teammates. I'm just messaging my team. Okay. All right. It doesn't seem to be a configuration issue as such. I don't know what has happened. So I'll have to take a look at it. Let me just copy paste the error message. So after a couple of tries, mine seems to work. That doesn't mean that this is right. Okay. No worries. So, all right, no worries. We'll do this again. Just try a couple of more times, maybe it works, because see what it is trying to do is whenever you are launching Hive, it is going to request a session from Yarn, and that session could be on any machine. So one or two machines, we're not able to figure out which machines exactly. Maybe when we look at it more, see now this time it worked. Okay. All right. So you can say show databases. Okay. You have to put semicolon here. Do control U, yeah, semicolon. Oh no, the command is still continuing. Just put semicolon. Yeah. Enter, semicolon, enter. Good. So you can see that these are the various databases. So you could try create database and other commands. Okay. Semicolon again. All right. So you can say use th10, use th10 MAR 2018. Right? Now you can define enter, semicolon. Okay. Now you say, right? Now you can say create table, space X, this X, bracket, the round bracket, the round one, not curly one, the one which is on 9. Okay, yeah, A space int, 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 semicolon, right, enter. Now you can say show tables. Okay, correct. So you can see X is there. You can say select star from X. Great, great. So yeah, it was all right. Now I can continue. I hope the same is going to work with others. All right. So a question from Hitendra is Hive. Okay, there are quite a few questions. Let me go from start. So Alvin is also not able to start. Alvin, are you able to do it now? A question from Sachin, can you show its corresponding code in Java in MapReduce? It's not possible, Sachin, because it's not generating the Java code, because it's directly calling the MapReduce and so on. Okay, all right, great. Now the question from David is, do we need a local directory? Do we need a local? Not really, not really. Okay, question from Hive, question from Minta is Hive case sensitive in keywords statement? Generally, the Hive is not case sensitive at all. Probably it would be case sensitive only in the case of mm, process, the definitions of some things, but I've not seen anything which is case sensitive so far. Everything is case insensitive, including the table name, including the SQL syntax. Okay, so it is case insensitive. Hiten's question is, so this seems like Hive configuration issue, like Hive limits have reached. It is not that, though Hive limits are pretty low, no matter what we do, it generally kind of blocks everything. But this wasn't the Hive limit related issue. In case it has reached the limit, what happens is that it kind of hangs, as in the prompt doesn't appear and it hangs there forever. Okay, that is the sign of the limit. A question from David, where is the Java IO temp directory environment defined for the property files? For the properties files, okay, interesting question. So it would be, all right, so which property files are we talking about, David? Ah, okay. Looks like one or two servers are suffering with that problem. That's why when you keep on trying again and again, it basically tries on other machines and then it works. Okay. A question from Hitendra is that what is Taze? Okay. What is Taze? Taze is basically an engine underlying the driver that I talked about. That basically is a pluggable component in Hive. By default, Hive comes with its own. Since we are using Hortonworks, so they basically have put their own engine instead of Hive's engine. If we use Spark, if we use say Cloudera, then Cloudera's underlying engine will be used instead of default Hive. Okay, so those are the basic SQL customization of SQL engines. Okay, so those engines are something that they keep on implementing and re-implementing. And a question from Sachin is, so how it is interacting with MapReduce? So basically, instead of writing code and then calling MapReduce, it directly basically interact with the MapReduce. Okay, all right. All right. A question from Bintao, how to change the names of the tables, attributes and values in the tables. We'll talk about that soon. A question from Robin regarding the alternative Spark. Are we going to access same Hadoop Jupyter at CloudxLab when we're creating jobs for Spark? That's right. That's right. Okay. All right. So it's going to be the same cluster. Everything is going to be same. Your data will be there and so on. Your data will be there in HDFS and in the local folder. All right. So we're going to take a break for 10 minutes and we'll continue from here. Okay. Break for 10 minutes and back by 9:43 p.m. IST. Okay. All right. So I'm back. Should we start now? All right.
Sandeep, one question.
Yes.
Yeah, so these queries which you have written, it will not generate a corresponding Java code in MapReduce?
Yeah. So I'll explain to this. It's a hard way to explain. One is there it won't generate right Java code. Instead, it will directly execute the MapReduce. Okay. It's like saying that when I run my C code, right? Does it generate assembly code? Okay. Does it generate assembly? Answer is no. All right. Because internally C code directly gets run there. Or how should I say? Basically, it is doing the MapReduce under the hood, but it is not really generating the Java code. Okay.
So which intermediate it will go to the MapReduce jobs?
It'll basically create an instance of the job object, and then we'll do exactly the way we were doing in our main method. Okay, so basically Hive will directly create its directly since Hive is a Java program, right? So Java program has access to the Hadoop's library and directly starts talking to the Hadoop. Okay, so it doesn't. So when let's say when you are using email library from Java, you don't necessarily need. It won't generate any code. It will directly use the mail server. In the same way, here also, it will directly use that. All right. So I don't think that it'll be generating the Java code as such. Okay. So, but it will be using the MapReduce. It will be launching the MapReduce job, and all of that will happen. Okay.
Yeah, so it will generate a MapReduce job, correct?
It will create the MapReduce job. It will launch the MapReduce job internally, but it won't necessarily generate a Java code.
Okay.
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 All right. Yeah, it's a good question, and many people have this question that it would be generating Java code. But as part of design, if you think about it, that when you are calling one program, calling another, like another Java program, it doesn't need to really generate the code. It can directly call it. All right. Like for example, when we were using Hadoop streaming, right? When you were using Hadoop streaming and calling it, we were not really generating the MapReduce Java code, right? We were directly calling it. All right. So are these okay? A question from Robin is regarding the March 1 Hadoop session, that installation session. What is the link to get a copy of the meeting saved chat Q&A? Also, is it normal that we can't access the actual Ambari created? So yeah, Q&A, I'll have to ask them. It's basically, we need to give you the link. Okay. Another question is, you're not able to access the Ambari that we created that day, all right? So we have basically uninstalled or destroyed those servers, so you may not be able to access that Ambari that we created. Okay. And how do we get copy of the saved configs? How do we get copy of the saved configs? And okay, saved configs as in okay, that exported one. Okay, just I would say that you should for any such questions, just send an email to reach us. Then one of us will respond. Okay, how to get a copy? Okay, let me just note it down and will inform. All right. Okay, I'll just ask somebody to send you. And so, great. So that's yeah. All right. Okay. Great. So, question from Sachin is, but I'm still confused. How is Hive is interacting with MapReduce? Basically, internally, it's creating the job. Instead of generating code for creating the job, it is internally just creating the job. In the same way, it is creating an instance of the mapper and reducer, which it has already defined the classes, and and then launching that MapReduce job. Okay, just like you see, when we gave Hadoop streaming our binaries to execute, it did not really generate the Java code, right? Hadoop streaming basically took our binary to run. It did not really generate the Java code. It just basically internally it created the job which was calling our programs. So that in the same way, Hive does not need to really generate the code and recompile it and then execute it. No, it can directly call MapReduce. All right. All right. A question from David is, for tomorrow's class, when we receive the next session email for the class, will it say 7:30 a.m. PT? Oh, good question. So we have not yet updated the time zone. So you will continue to receive the time with respect to the old time, right? So we need to, um, the answer would be that whatever is with respect to IST. So tomorrow when I do in Google, if I do say uh, 8 p.m. in say PT, right? 8 p.m. IST in PT, right? So as of now, it is giving 6:30 a.m. Saturday, right? Tomorrow it would be giving something else. Okay, I'll have to ask somebody. Okay, all right. Good. Let's move on. I see. Of course, point from Binta is that some of us will have 1 hour less sleep tomorrow. I see. Okay. Sure, David. We can circle back and review these tools towards the end. Okay, great, great. All right. Uh, okay, okay. So could you try the Hive again? We have restarted it, and the disk space should not be a problem. Could anybody give it a try? Are you still facing the same problem? Okay, let me just open the terminal and see how it goes. Okay. This seems to work now. But the same error that we faced today, we also faced a similar error while we were running the MapReduce job. Okay, so there was something to do with it. All right, good. So let's move on now. Moving ahead. Now, in Hive, other than this, in Hive, so we were all able to create our first table happily. Okay, we were able to create first table. Okay, so one more thing I would like to demonstrate at later point of time is where is the file. That's the most important concept. So there are two kinds of tables in Hive. The first one is called managed tables, and second one is called external tables. So there are two kind of tables, managed and external. Managed is something that you own, as in if you delete these tables, the underlying data will be deleted. The external tables are those which you don't own, as in if you delete these tables, then data will not be deleted. So I would suggest that you just say, for most of the data, just keep them external tables. Because if you by mistake delete a table, all the data is going to be deleted. All right. So managed tables or internal tables are basically same thing. The lifecycle is managed by Hive. Data is stored in HDFS in the warehouse directory, and dropping the table deletes the data from warehouse. Okay, while external table, the lifecycle is not managed by Hive. Dropping the table will only delete the metadata or the table definition, but the underlying folder will remain the same. Okay, so dropping the table does not delete the underlying data. So metadata will be deleted, but nothing else will be touched. So let's start with creating a simple table. And so first of all, let's log in and create this table. Okay, there are two ways to create it. One using the Hive and other using the command line. Command line we have already tried. So this one I'm going to try is the web interface. How do I go to the web interface? I'll just click on Hive, right? I'll just click on Hive, and in the Hive, I could say query editors Hive. Okay, so here we are creating the table, right? So we are saying we are creating NYSE, right? And this is exchange one, symbol one, YMD, price open, high, low, and so on. These are the column names. And then in the last, we are telling that the data, that underlying data is going to be delimited based on the tab. A question is how to distinguish two tables. Okay. Also, When you are here, just select the right database. What was my database name? SG underscore something, right? What was SG underscore 18 March 18. What was that? Not 10 March, I think. Okay, we created some database, right? Okay, so I'm just going to use that one because this drop down here is not really great. So it's generally better to, okay, all right. So I said 20 March instead of 10 March, okay. So use this and I'm going to execute this. All right. So you can see, okay. I'm just hoping SG underscore 20 March 18. I hope this works. Oh, it doesn't. Never mind. So I'm just going to use this. All right. Because this dropdown is a little buggy, so it doesn't show up all the while. And therefore, I'm just going to use from here. Next step I'm going to do is I'm going to paste my query. Okay. So it says that there is an error in this one. Okay, so I've created a table called NYSE. Okay, we have created a table called NYSE, and I could take a look at describe NYSE, and I can just select this and execute this. Okay, so this is my table. Okay, you want me to give you these commands? Okay, all right. So you can say describe formatted. Okay, so formatted. Describe formatted is okay. Now here what you see is okay, not really this one. I'll just use my own database and execute the command. Okay, I'll just execute these both of them together. Okay, so you can see that the database owner is Sandeep Giri 9034. You can see that. And at the same time, if you take a look at it, it is a managed table. Okay, so without this is how you can distinguish between the tables. All right. Okay. How can I run selected query command? You can just select it and execute it. Okay. All right. So what we are trying to do is we are trying to execute, we are trying to create a table and we are trying to see what's there inside the table or understand the information about a table. A question from Grishma is, what does formatted means? Formatted basically gives you a well-formatted output. Otherwise, it actually is not well formatted. Okay, that's why. Okay. A question from Robin is, in the hue in the screen now, is there a way we can modify, edit the results via GUI table executed? Uh, it's not possible using this UI, but there is a better UI here. There is called Metastore tables. You can create a table using Metastore tables. Okay. All right. So you can actually okay, you can actually create a table from a file. Okay, you can actually create a table from a file and it will automatically suggest the columns and so on. Okay, so that's one thing possible using the Metastore tables. Also, it should be, yeah, that's the one. So, or you can create the table manually. Okay, so there are two parts we talked about. One is Metastore tables, other is this Hive. This Hive is a general query engine, and we can't really modify the results because, okay, because here it's the output. So, and it does not allow us to modify the tables. Okay, good. Now, going ahead, and now next step is that we, okay, great. So next thing is we are going to make a copy of, instead of this loading local, I'll first do it from the HDFS. Okay, now next thing I wanted to show you is this, that when we created this table called NYSE, it created a folder in the warehouse. So how do we look at the warehouse? It is in the HDFS. So let's go to HDFS. Okay. All right. Let's go to HDFS and go to apps, Hive, and warehouse. Apps, Hive, and warehouse. So whatever table I just now created, I would like to take a look at where is the data. In this folder, you will find that there is in the warehouse folder, there will be a folder for my database. Okay, where is that folder? This is the one, right? No, this is the one. Okay, this is that folder. This is that folder that we just now talked about. Okay, so you can see that this table, this database has my two folders. One is X, other is NYSE. X has no files in it, you see. Therefore, there is no data in it. I can say select star from X, select star from X, and select star from X, and take a look at it. There will be nothing in it. Okay. So you can go to file browser. You could go to file browser, go to warehouse, apps, Hive warehouse, and then how to go there? Just click on this top level slash. Okay. If you click on file browser, then you will see this. Click on this top level slash, and then you click on apps. Then you click on Hive. Then click on warehouse. Then type the first few letters. Yeah. So it has SG underscore. Oh, somebody deleted it or what? Okay. Looks like somebody has deleted my folder. Okay. No, this is the one. Sorry. I think this is the one. Correct. Okay. All right. Since you have not created any tables, you will not see anything. Since I created two tables, one is using this here, using the command that I shared with you. Okay. And probably why it's not showing up for you is probably you did not select your database. Okay, I did select my database using use command, and while executing, I selected both the statement. Okay. All right, Rajan's question is, I also don't see my tables, and yeah, the reason is that probably you created in default database. Okay, so I'll just show you, probably it would be there in the default database. Okay. Okay. What's the name of the table? What was the database, Anur? Okay. So you can see, use this, select star, or you can just say show tables. Okay, I'm just selecting the two and take a look at it. It's there, right? NYSE, correct? So it would be, the warehouse would be there. Warehouse would be there. Okay, let me just go to say warehouse and look for your folder. Okay, so you can see the folders. Okay, one more thing, everybody, one more thing is that when you have typed something here in the text box, right, it keeps on filtering it. Therefore, you have to remove this. Like I searched for Rajan, and that's the reason. Okay, so this text box basically is sticky. Even if you have gone to another folder, the text box remains the same text. Okay, so the filter was generally an issue. It's a very counterintuitive. Grishma, is the same issue with you also?
Hello, Sandeep. I don't see anything actually. I haven't selected anything.
Mm-hmm. Okay,
Nothing is
so
showing.
and it's showing in your hue.
If I write a command show tables, it is I can execute and see all the tables, and even on Jupyter I can see. But
Oh,
through these, I mean, if I
can you,
go,
yeah, can you show me?
yeah, let me share.
All right.
See here, nothing I can see.
Okay. No, GC is still selected at the top. You see?
Yeah.
Go back there. I'll show you.
Okay.
I got the error. You see the text box at the top? You see, just
Oh,
yeah, yeah. That's the main
okay.
issue. This is a bad design of the interface. It's not your fault. It's actually the bad design. Okay.
Okay.
All right. So no matter how many times I explained to the Hugh guys, they did not understand this. I actually wrote to them. Okay. And all right. Good. Good. So all right.
So you is provided by which vendor, Sandeep? I forgot actually.
Cloudera.
Okay.
Okay. So we've taken Hue from Cloudera, and the rest of it is from Hortonworks, and that's how it is. Okay. Great. So all right.
Sandeep,
So
I am not able to open my folder test sec.
okay. Okay. Show me.
Yeah.
This is
Yeah.
Subbu.
Where should I?
Yeah. Click on it.
Yeah, I'm clicking,
Yeah.
but it's not going.
Uh, uh, is it? Just refresh this, Avan. Just, yeah, enter.
Yeah,
And see
not.
that?
Yeah,
Okay.
what is NYSE and X?
These are the tables that you created.
Okay.
Okay.
Yeah.
So, all right. So this is the first thing that we did. Now, okay, I'm going to show you the, all right. Now, I'm going to show you some cool thing here. And okay, again, I have to go there. All right, great. So what we have is, let's say X table, right? You remember the X table? It has nothing right now, nothing. So one way to upload data into this table is right away create a file in this. Okay, so let me show you what is there in my table right now. There is nothing, correct? There is nothing, and it is not showing anything, correct? Now, since it has only one column and that column is integer based, so I could right away go here and create a file here saying create a file. Okay, and could say this is first data file. It could be any name. Okay, data file. Okay, and you see this empty file. Now I'm going to just edit this file. I'm going to edit this file and put some data into it. Okay, okay, so this, I've just created this data. So I'm going to what we're showing you is that in the warehouse directory, the table, it has created a folder. In that folder, if I just put the data directly, then also it interprets very, very well. Okay, so you can see that if I do this here now, okay, it has loaded the data. Okay, so if I just copy the files there in the format that I defined earlier, then it would start querying that data directly. Okay, that's the easiest way to get started. All right, a question from Sachin is, can you see my database test AC? Okay, let me take a look at your database. Okay, in the meantime, others can actually, okay, and all right.
Yes, Sandeep, you have seen just now. I shared my screen now, that you have
Okay,
seen.
okay,
Yeah,
cool.
one question. This app Hive,
Mhm.
this is a HDFS path.
Yes, it is inside HDFS. We went through file browser, right? Which is
Yeah.
HDFS. So this is basically a Hive database using HDFS for its data.
Okay, to storing it.
Correct. So whenever we create a database, it creates a folder here, right? It creates a folder here whenever we create a database, and inside this, it creates one folder for each of our tables.
Yes, correct.
So a question from Noor. So this is actually not a DB system, but just a SQL interface over text file. Wonderful. Yes, that's right. Not over the text, not only the text file, but we can also specify the binary formats of the data. All right. Good. The Sure. Just one more question. Let me answer the question. A question is from Robin. One more thing, Binta, are you able to uh, create the database? Okay, can you just tell me? I cannot see the tables NYC created by me under the warehouse. Okay, but the table is not visible. Oh, okay now. Good. All right, so it's working great. Okay. Now, question from Robin was just wondering. I encountered the the encountered the error below when I execute error compiling. Okay, good. Can you show me the screen? All right, so you have to just put the semicolon after the use statement just before create. Just put the semicolon that will end the use command, and that would do. Okay, yeah. All right. So essentially, when you are not selecting any query per se in this text editor, it executes everything from the top till at this point. Okay. Great. Great. All right. Wonderful. So I'm really happy that most of you are able to do hands-on as we are discussing. Okay. That's the biggest advantage we have with respect to an online lab. Okay. So wonderful. Wonderful. So all of you are able to do that. Great. Great. The next, okay, so the next thing I try to show you is that inside this folder, we just added one file, okay? And in this file, we just added some numbers. We could basically, again, either edit it, okay, if we just edited something and just execute or add more data in this folder. If we add more data in this folder, you will see that you will see that data is getting concatenated. A question is, how did you create this file? I went here, clicked on new and clicked on file, and then I provided the name for this file. Okay. Okay. So right now I'm not operating on the tables. I'm basically, I went to this folder where for each of my tables, it has created this HDFS folder where it's going to put the data. So what I did was I added a file there directly in that folder, and then when I go back to my query, it is going to just read the data. Okay. So here, this is my new data. All right. So this is what I'm going to just say, add more, 45, 9, and 111. Now, if I go back here and query this, whatever data I put it in the warehouse folder inside the folder for my table, it is here. You can see that it is here. So you can always think of Hive as um, a query engine over your data lying somewhere. Okay. A question from Binta is, I can see the tables. However, I cannot open them by directly clicking. Why? You mean this one or in the warehouse? Under warehouse. Okay. Can I take a look? Okay. I think this problem, uh, can you show me? I would love to see, because I think the same problem was faced by Robin also. Okay, good, good. All right. Okay. Now the click is working. Yeah, here. So there is nothing in this right now. Go up one more. Yeah, yes. Yeah, you can go there. Click on X, let's say. Yeah. Say here, create a new file using new. Increase the window size. Increase the window size. That'll be better. If you increase the window size, that will appear on the right. Just increase the window size, please. The window, yeah. Now you can see there is a new button on the right hand side. New file. Okay. Just put some file name. Okay, create. And just click on that. Okay. Click on edit file. There is an edit file action on the left hand side. And just put some number. No, number. Otherwise it will give an error. Just put one number, enter, another number, enter, and save. Okay, so you have just saved the data directly. We are just tweaking the data there. Okay, although it's not a recommended way of using Hive, but it's important to get the feel of where is my data, just to get the feel of the sentence which Noor was saying, that it's not a DB system, just a query interface over the file. Yes. Okay, now go to Hue go to Hive, and then try to execute the command like select star from X. Okay. Yeah, say select star from X, or you can just click on the table on the left-hand side and you will see the results. X, say X, because X was the table, right? Not the file. There was a folder for the table. In that, there could be many files. You can see that? It's basically querying over that file. All right. Great. Just like we wrote our MapReduce over the file or the folder, similarly, it is doing that. Great, great. So, okay. A question from Noor is, so if we have multiple files, then it's concatenating the files and showing as a single table. A question from Hitendra is, does Hive create new tabs in the browser when you jump from query browser? No, it doesn't do that. Okay, just by adding files, it adds to the table. So Hive is just SQL layer over the files. Kind of, yes. Okay, so it has many file formats and it can read from other sources as well. But in classic sense, it is that. Okay, so right. Thank you, Noor and Hitendra, for the question. Good. So the next thing which we were trying to do is we were trying to load data from HDFS. So we created this table. Okay, we created this table called NYSE HDFS. Okay, I've just created NYSE, so no worries. Next thing is we are going to copy. Okay, this time instead of directly tweaking the data, we are going to go formally and go follow what uh, generally people do. So we are going to copy the data from a central position, central location to our home directory, first of all, okay? So that we don't intervene with the existing data. So we are going to copy this folder into our home directory. And how do you do that? How do you do that? We go to say Hive. What was the folder name? The folder name is /data and NYSE daily. Okay, so we are going to go here and say /data and select NYSE daily. Okay, and then we copy this to our home directory. Where is our home directory? You click on the home and you get this and we get it. We could also use Hadoop FSCP. So it has copied this folder in my home directory. Let me just take a look at it by sorting the data by date. So what was the name of the folder? NYSE. Yeah, this is the folder it has created just now. Okay. Now, next thing is that this, you can see that it has copied the folder. How did I do that? I went to that particular folder. I went to this particular folder. Okay, and clicked on copy. And then I selected my home directory and then said, okay. So this is the one. All right. So instead of directly going and uploading file there, we are going to use this particular file for loading data. A question from Hitendra is, what if you add a file under x.db but with a different layout? Then it'll basically not be able to read that data and will show empty when you say select star from table. You could experiment with that. Okay. All right. So we are copying this /data NYSE, this folder, from the central location to my home directory. Right now, we are just copying the files. Okay. Then we will load this file into the table we just created called NYSE. Okay. Now, good point. Good point. So question here is, what does it mean by this? Okay. What does it mean by this? It means that my data is tab separated. My data is tab separate. There could be many formats in which the data file could be. Therefore, we need to tell Hive that while reading this data, please use the tab as the delimiter. Okay. And you can see that why are we saying this? Because this data that we are going to load is tab separated. You can see that it is tab separated. All right. So this is the data that we are going to load into our table. Okay. A question from David is, please walk through the copying file again. Sure, I'll do that. So you go to file browser, click on the top slash, then click on the data. Okay. Then you select this folder called nyse_daily. Done. And then, so you go to click on the top level slash just after the home icon here. Then you click on data in the folder structure. Then you select NYSE daily. Okay. And then click on here actions and then copy. Okay. Then you click on home and that's it. Okay. Does anybody wants to give it a try? I can just make you the presenter, or you can just be the presenter, David, or anybody. All right. So go to file browser, click on slash. Yes. Then click on data. No, just click on data, not checkbox. Okay. Then, yeah, select the folder, do the checkbox, yes. Okay. Click on copy. Can you hold on here? All right. Okay. Now click on home just at the top. Yeah, that's the home one. Okay. Now click on copy. Essentially, we are copying the slash data NYSE folder into our home directory. That's as simple as that. Now you click on home. Click on home. Yes. There you have this folder. Good. All right. All right. So here is this data that you have just copied from a central location to your home one. Okay. Now, parallelly, you could open another terminal, another Hive window, or you could just right click on query editors and try to open that. Yeah. Open link, new window. Yeah. Okay. New tab. Yes. Click on query editors again. Yeah. Here. Hive. Okay. Now, can you just select your database and show me the table that you have created, NYSE? I think you need to, did you create a database of yourself also?
Yes, yes.
Okay, just select the database, either using use or using something. Yeah, log will be a better option. Okay. Okay, cool. So here you can say just after use test SSE. Okay.
what I need to give?
Here, say select star from NYSE. Okay, select star from NYSE. Enter, as in click on execute. Let's just take a look at it. Okay, so it looks like there is no data as such. So now is the next step. I'm going to just give you the query. You execute the query. You stay there. Okay. Next thing we're going to do is we are going to say here load. Okay. In the chat, I have posted this query. Replace the replace the Abhinav 9884 with your account. Okay. So copy paste that query into the text editor. Yeah, change Abhinav 9884 to your login. Your login will be Sachin Sikri 239. Okay. 239576. Okay, good. Now after this you can write another select star from NYSE or something. Okay, just run the entire execute. Okay, let's take a look at it if it's giving error or are we getting the results or not. Okay, so again select only first two lines and then execute. Let's take a look. Just select first two lines. Yeah, first two lines. Okay. What is restart? Is it? Oh, the query was still executing. Oh, I see. Okay. Can you run this whole thing again? Load data in path along with the use. Yeah, just run the whole thing again. Let's take a look at it. Can you select log below? I think it is happening. It is running still. Click on log. There is a log column. Okay. Recent queries. Okay. All right. Okay, this is strange. The table exists, right? NYSE?
Yeah, I created.
Okay. Yes. Okay. Now, I'm just wondering what happened. Why it's not working? Just select first two records and or is it still running? Try a smaller case. Can you just try? Wow, what's wrong with it? Anybody? NYSE daily into this, select star from NYSE. This looks okay, right? Okay, let me also try the same thing in my tab. Just let you keep it open there. I will also do the same thing. Okay, so what I'm going to do is load data in path. I'll say Sandeep Giri 9034 and then okay, and there I go. Load data in path HDFS user NYSE daily and overwrite into this. Just a second, I made a mistake here. And Okay, can you just show write a statement just between 1 and 2 line, say just after use, say show tables, and just select the first 2 lines and execute. Select the first 2 lines and execute. Yeah. Okay, NYSE is there. Okay, and still it is empty. All right. Okay, for me it worked. I don't know what's wrong with this one. We copied, right? It was there. The data was there. Could you just go to that warehouse folder again? What was that folder? Yeah, that's the one. Remove that text box. Clear the text box. Yeah, the text box is there, na, above. We have to remove that. Just go above where you typed text AC. Remove that. Remove that. No? Delete this. Yeah. Okay. Just go to NYSE. All right. It's not there. Okay. So go back to the hue. Maybe we'll have to drop the table, create the table again, and then experiment with it. Okay. So okay. So maybe in this line we can just drop the table. We can say drop table, or just create another table. Maybe just create another table. Okay, with different name. Yeah, here just put a create table statement. Should I give you the create table statement? Okay, so here I go. I'm just going to give you this table called NYSE. Okay, so I've just given you this index. You can use that one. Create table NYSE underscore HDFS and copy paste that. So first statement has to be use database. Second is create table statement. And third is remove select star from NYSE now. The 15th line. Yeah, no, only the 15th line. 15th line, only the 15th line. Yes, delete it. Now here in the table NYSE, the 17th line, go to the end. Change the name of the file to NYSE underscore HDFS. Okay. And the 18th line, change it to select star from NYSE underscore HDFS. Okay. Now execute this. Maybe select everything and then run. That's okay. Yeah. This time it is loading it. It is loading. So this is working fine. I don't know what has gone wrong in the first attempt, but this time it is working fine. All right. So we are able to load data from HDFS into our table. Now go back to Hue. Go back to Hue, Sachin. As in that file browser. Yeah, good. Go back to your home directory. Click on home. Yes. And here, go to that folder. Do you see that folder, NYSE daily? So this data, when you load the data gets moved. Why? Because in HDFS already there are 3 replica factor of 3. So it's a design call which the Hive guys have made, that while you load the data, it moves the data rather than copying the data. And at this point, if you drop the table, data will be gone. It is not in your home directory and it won't be there in the warehouse. Okay. So if you drop at this point, because it's a managed table, and therefore there is a problem. All right. So I hope this was clear. We were able to do two things. One is all right, Sachin?
Yeah, so we have downloaded the data from HDFS to Hive. Correct.
We loaded the data from HDFS to Hive, which is actually just equivalent of copying the data moving the data from one folder to another. Okay.
Yeah, sure.
All right. Great. Great. Wonderful. So yes, thank you, Hitendra. Yes, that could have been another way. Okay. Okay. All right. All right. So good. Good. So, all right. So question from Grishma is that it worked. Hitendra, is another way to just copy the file. Yes, that is another way. And yes. So David is saying that it seems to me it throws miscellaneous error when server is busy. Yes, it kind of does that sometimes. And Grishma's point is that it overwrites the existing data. So it depends on the command that we are using. Here we are saying load data, and then we are saying overwrite. If we skip this overwrite, it is going to essentially copy this data once more. So there will be duplicacy of the records. Okay, if you have already done it. So it won't overwrite, it will just create some more records. Good. Now, once you have done that, once we have done this kind of thing, once we have done this, so we have loaded the text data into a table. Now we can do all kinds of magic over this data. Had this been data in few terabytes or few hundred terabytes, you can still happily execute your SQL queries. Okay. So for example, let me show you that if I want to just find the average value of this symbol, all I'll do is I'll say group by CLI, right? And here I'll say CLI and say average of say price open. Okay, average of price underscore open. So I can easily create these complex queries which are under the hood running the MapReduce job. Okay. So which are under the hood running the MapReduce job. All right. What's with these? I'll just refresh or reload this. Okay. Or just click on query. It has little strange UI. So select CLI, comma, average of price open from NYSE, group by CLI. Okay. This is no, it's actually just takes you there. Okay. So select star from, let me just say, select star from NYSE. Okay. So star from NYSE. This is the simple query. Okay. Then we are saying here that, oh, there was no symbol one. Okay, group by CLI. No, we were not supposed to do CLI. We were supposed to do symbol one. Okay. Thank you, Rajan. Thank you very much. So I feel like, okay, great. So you're right. So it is supposed to be symbol 1. Okay, so instead of giving proper error, it just doesn't show anything. Okay, so it's taking some time to execute. You can see that it is executing the query on the yarn cluster. Okay, so here it shows it is running on the yarn cluster with this application ID, and this is the work that's going on. If you don't believe me, you can go to the job browser, and I'm pressing Control before opening this. So in the job browser, you can see that this query was still running for me. Okay, let it finish, then it will be showing you us a proper message. Okay, so in simple words, that it is executing on yarn. A question is, where is MapReduce here? So okay, so I think the Tez is executing MapReduce here. See, so internally when we are saying select symbol 1, okay, and average price from this group by symbol 1, internally it would be doing all of the magic for us. It'll be creating key based on the symbol and then grouping it and creating in the reduce, it'll be averaging the value. Okay, so this is under the hood running as MapReduce. All right, Sachin. It's not storing in HDFS right now. It is just showing us results in the UI. That's all. Okay. We'll talk about how to save it in the HDFS. Great. All right. So all right. So we could load the data into an HDFS table. In the same way, we could create an external table, no difference at all. We could just create an external table, load the data there, and happily use it. Okay. The Excel table could be created on top of a remote database, remote file, such as, let's say you have some data lying in S3, you could create an external table. And here, in the location, we could say S3N colon, and then here your bucket name and so on. So basically, you could create a Hive table on top of this data. But remember, whenever you run the query, it's going to download that data from S3 in order to query. Okay. Also, the Hive has the standard select statement like select star from this table, select this, select that. All of the standard SQL you can do using Hive. Okay. Also, you could do the average operations like this. If you want to further improve the performance, you could say that they do some of the operation aggregations inside the map side itself. Okay, but you would not notice any much of a difference by using this flag because the data is not that big. Then if you want to save this data to a local file or to HDFS, we'll use this one because local file one doesn't make sense in production environment because you never get to access to the local file. Okay, so here we could save this data to whatever we did just now, these results into a particular folder. Say, let's say I'm trying to save the symbol, the outcome of select star from NYSE where symbol equals CMC. Okay, or I'm saying select star override this, and whatever I did earlier, it's I'll just give it a good name, group by NYSE, and I'll say by symbol. Okay, Okay, NYSE prices by symbol. So it will basically compute this result, the result of this one, and save it in this particular directory. Okay. Okay, let me just take a look at it. It says again the same error. Could not find a valid directory. Okay, remember this yarn task that happened earlier? So we are trying to debug this, and this keeps coming from time and again. Okay, let me just do it again. I hope the folder is not already created. I'll just see. Did it create any folder? No. Okay, only the temporary files have been created. I'll just delete this folder and try again. Okay. Vertex did not fail, did not succeed because of whatever reason. All right, it has started throwing the same error again to me. All right, maybe I'll try after a while. Okay. All right, no worries. So we could demonstrate this probably later. Okay, this worked. So here you can see that it had generated this folder here, and it has this file. Okay, so it has saved the results here. All right. Also notice that it has basically just concatenated them continuously without specifying tab. So we can specify tab while saving this. All right. So this was our quick interaction with Hive. We're going to go more details. We're going to go more over a couple of more things. All right. A question from Grishma is, can you please explain the major difference between external and managed? To be honest, the major difference between external and managed is when you delete the table, if the table is managed, the data is going to be deleted. If it is external, then it's not going to be. The other difference is external table can be mounted from using a remote directory. Okay, so the file will be, yeah. Another question from Grishma is, so the folder will be created under the query executors directory, correct? All right. Hitend's question, so the folder will be created under the query. It will be created if you don't provide absolute path. If you provide the relative path, then it will save in your home directory. If you provide the absolute path, then it will be saved there. A question from Hitendra is, the group by only runs once. Actually, there's something wrong with this cluster, and we need to take a look at it. That's what we are also taking a look at it. the some of the jobs are randomly failing. So we need to just review the cluster. All right. So that's something that was happening earlier also when we were doing something in when we were executing the streaming job. So that was also happening that time. All right. A question from Hitendra is, are query results saved anywhere? So that's what I was showing you, that when you run a query like this, you can save the results somewhere, okay? Using insert override directory. Otherwise, it doesn't save. Okay, good question. Now, a question from Robin, just to verify what type of managed table have we been doing? So we have been using managed tables so far, not external. Okay. The standard command like alter table this, alter table that, all of those are valid in case of Hive also. Let's say you want to rename table or you want to change the data type of a column. And if you want to add more columns, then you can do that even in Hive table. Okay. All right. A question from Grisma is that please show us an example of external table drop where data is not lost. So you can actually, whatever we did just now, you can just put external keyword over there and then load the data and drop the table. You will see that the data will remain as such. Okay. A question from question from Noor is there insert into table command? It wasn't there, but now in the new versions, the insert into table is there. Okay. A question from Inta is, once data is loaded, it will be removed from the current location. If I want to load it in another location, I have to load it from the original. Yeah, whenever we are using the load command moves the data from in the HDFS. Okay, so you have to try doing that again. Okay, a question from Robin is, are we performing external tables as well? Not yet, but there is not much of a difference. You can just say external and you can start doing that. A question from David is, select symbol 1, count this, count star, and CND, and average price, and group by symbol 1. So if you are grouping the data based on symbol 1, okay, then you can only do aggregate on remaining one. Okay, that's correct. So I think the query should be correct. Let me just try this. Let me try this. Okay, so let's just do this. Should work because these are aggregations on remaining columns. So it looks like it is working. Good. So basically, okay, good. So basically the average closing price, average opening price, and total counts per symbol. So you can actually execute a very sophisticated queries on Hive. Thank you, David, for this. All right, is there a further question on this? All right. So tomorrow we'll start with Hive partitions. Okay, tomorrow we'll start with Hive partitions and then we will start with NoSQL and HBase. All right, see you tomorrow. Have a good day. I hope I was able to answer your questions. A question from Inta is, what will happen if the table schema is different with the loading format of the file? Good question. If the loading format is of different format and you are using a different schema, you're going to get empty data. All right, going to get empty data. You can try changing the format so of the data which we have loaded, and then you will get the answer. All right, wonderful set of questions. I look forward to see you tomorrow again at the same time.